Hello everyone, welcome to this new video. So like this right now the time is 2018 p.m. IST. So maybe in 30 or 45 minutes later you people might see this video. So the reason why I'm uploading it right away is right now we are actually celebrating Diwali on this day. So I feel on this occasion it's good like if we learn something new and I be a reason for it. And you people might actually face a lot of background noise due to crackers and all. So I request viewers to not to please like don't mind it. And I also made sure like the sound of mine is audible enough. So like it will not cause a lot of disturbance. So but still, yeah. And also keeping the time factor in mind, I thought of not to write anything right now. Like I mean, I don't want to write simultaneously and then teach. So what I did is I just written all these things that I've actually did for PDF. So I'll be using that and teaching like teaching the solution of the problem simultaneously without writing any other stuff. So we shall go into the problem now. So the question is, three straight lines are drawn through a point P lying in interior of triangle element. So this is a triangle element and parallel to its sides. So that means you can see here like VS is side is parallel to ML and QT side is parallel to MN and UR side, yeah, UR side is parallel to NL. Fine. So this is the case. And the areas of the three resulting triangles are A1, A2, A3 with P as the vertex. So you can see for all these triangles, like this triangle has a area as A1 and it has a vertex P. This triangle has the area as A2 and vertex P. This triangle has the area A3 and vertex P. And let the area of the triangle element is delta. So the total area of this triangle, the bigger triangle, is delta. And the relation between the delta A1, A2, A3 is given as delta is equal to root over A1 plus root A2 plus root A3 whole power k. So now it's a combination type questions. So I'm actually focusing on these type of questions so that it will be helpful for people who are actually trying out for some competitive examinations. At the same case, like at the same time, people who love to solve math will also be getting like combo package. Okay, so they'll also enjoy it. And the other question is, which is relatable to the value of k. So that is x1 into x1 minus x2 into x1 minus x3 into x1 minus x4 is equal to k square is one equation. Similarly, x2 into x2 minus x1, x2 minus x3, x2 minus x4, and x3 into x3 minus x1 into x3 minus x2 into x3 minus x4, and x4 into x4 minus x1 into x4 minus x2 into x4 minus x3. So all this equal to k square. So once we find the value of k, then we can solve this problem. And we also then what we actually need to find, so we need to actually find the value of x1, x2, x3, x4. Fine. So let us first find the value of k. So how do we proceed? First thing is, we must observe that when the lines are parallel and actually passing through a same point, that means concurrent at point P, then the triangles being formed will be similar. So what triangles will be similar? All the triangles that are being formed, like PUV is the triangle, I mean the triangles, the smaller triangles that are being formed will be similar to the bigger triangle, and also they will be similar within themselves. So triangle PUV is similar to triangle PTS, is similar to triangle PQR, is similar to triangle element. So like people were so confused, like why is this so? This is like this is being left as a task for you people. Okay, so this is not at all a big deal, a very easy question. So you people can just have a look onto it carefully, then you people can understand by yourself. So then, if triangles are similar, if two triangles are similar, then the area of their the ratio of the areas will be equal to the ratio of squares of their sides, isn't it? So that is the principle we are using. So area of triangle PUV divided by area of triangle LMN, because this triangle is similar to the bigger triangle, so this is equal to UV square divided by Mn square. Fine. So Mn is the side length of this, like the bigger triangle. So this is Mn and this is UV. So UV square by Mn square. Similarly, which is also equal to PU square. So PU square and the side similar to it. So which is which side is similar to that? So that is ln. Fine. So pu square divided by ln square, and which is equal to pv square divided by lm square. So this is how it is, and we know that triangle PUV is A1, so we consider it as A1. Fine, it's up to you, like what to imagine, like what to assume. So A1 by delta is equal to UV square by Mn square is equal to PU square by Ln square is equal to PV square by Lm square. Similarly, for A2 by delta, you can just write the same thing for this, and A3 by delta. Now, from the above relations, what can we take as consider any one side. Fine, I have considered the side Mn. So Mn is what I've considered, and that will be seeing later. But before that, we can see from here, we can see that uv is actually equal to mn square into a1 by delta. So uv is equal to root over a1 by root delta into mn. Similarly, pq is equal to mn into root over a2 by root delta. From here, pt is equal to mn into root a3 by root delta. So why I've considered this? Because I've considered mn as my side, so I made sure like every term gets mn into it. So in this term we have mn, in this term we have mn, in this term we have mn. So that's the reason I've got all those into this. And now what's the use of this? So thing is, we can actually clearly identify that pq is actually equal to vm. So you can see that pq is actually equal to vm. Why? Because this is a parallelogram and opposite sides are equal. So using that logic. And similarly pt, screen the pt, so pt is equal to nu, pt is equal to nu. So using that logic, and also we need to keep this in mind that we have mn to be mv plus vu plus un. We have uv value, so instead of pq we can substitute vm, instead of pt we can substitute nu. So that means if I just add them up, so this is how it looks. So mn is equal to uv plus pq plus pt, isn't it? And now instead of uv I've added this, instead of pq I've put this, and instead of pt I've put this. Fine. So this is how I converted them. And when you take the common, like mn, you get this. So mn gets cancelled on both sides, and finally we'll be remained with root delta is equal to root over a1 plus root a2 plus root a3. So that is delta square is equal to root over a1 plus root a2 plus root a3 whole square, and that is therefore k is equal to 2. So this is the value of k, right? So this is the value of k, so k is equal to 2. Now the equations are, so the equation transforms to be, this is k square, this which what we have in the RHS of the equations, so that is 2 square. So that means 2 square 4, so 4 4 4 4. So these are the equations. So what are the conclusions that can be drawn from these 4 equations? That is, none of the x1 x2 x3 x4 is 0. Why? If I put x1 is equal to 0, then this whole equation will be 0, which is not equal to 4. So x1 cannot be 0. Similarly, x2 cannot be 0, x3 cannot be 0, x4 cannot be 0. So you can just put not equal to. Fine. Like generally the symbols means that is equal to. Fine. So not equal to. And no 2 of x1 x2 x3 x4 should be equal. If x1 is equal to x2, then this will all be 0. And if x2 is equal to x3, this all will be 0. And if x2 is equal to x4, so you can just see here, then this whole will be 0. So comparing all these things, we can tell that none of them will be equal. So now what to do? So now let us assume some polynomial, fine, some polynomial g of y is equal to y minus x1 into y minus x2 into y minus x3 into y minus x4. So differentiating it, we get g dash of y. I hope you know the uv rule case. Now it is uvwz, so you can just differentiate it accordingly. Now g dash of x1 is equal to, see, when you put y is equal to x1, only this term will be left, the other terms will be 0. This is 0, this is 0, this is 0. Fine. So only this term will be left, and when you multiply by x1 on the numerator and denominator, this is what we get. And what is this value? From this we can actually see that the value of this is x1, this total value is 4, x1 into x1 minus x2 into x2 minus x3 into x minus x4 is equal to 4. So this becomes 4 by x1. Fine. So this is how we do it. And now similarly, so g dash of x2 is equal to 4 by x2, g dash of x3 is equal to 4 by x3, g dash of x4 is equal to 4 by x4. So I can generalize this as g of xi is equal to 4 by xi. So what are all the values that I can take? I can be 1, 2, 3, 4. So on multiplying this xi to the like taking this xi to the LHS and simplifying this, we get this into this form, that is g dash of xi into xi minus 4 is equal to 0. So from this, the roots of the above equations are x1, x2, x3, x4. We can clearly see that, isn't it? So we can clearly see that the roots of this equation, This equation are x1, x2, x3, x4. So now consider all the facts till now what we have, the conclusions that we have drawn and all those things. We can say that g dash of y into y minus 4 is a polynomial of degree 4 with coefficient of x power 4 being 4. So how did we actually get that? Fine. How did we actually get that? We can see this is the g dash of y, isn't it? G dash of y. Don't put any x1, x2, x3, x4 in the place of y. So this appears to be, this is y cube. Here we get 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 y cube. With coefficient of y cube being 1, 1, 1, 1. Fine. This is what we're gonna get. And even in this case, this value g of y, when you just simplify it, we get y power 4. And what's the coefficient of y power 4? That is 1, isn't it? So from all these conclusions, we can actually say that this polynomial is like g dash of y into y minus 4. Fine. We are not just talking about the polynomial g of y. Fine. We are not just talking about the g of y. We are talking about the polynomial g dash of y into y minus 4. Fine. So what are the things that we need to keep in mind is the coefficient of x power 4 in g of y is 1. And here also in g dash of this y, the coefficient of y cube is 1. So from this we can actually say that this polynomial is of degree 4. So this total polynomial, because g dash of y is a cubic polynomial, and this y, when you just multiply it with y, you get y power 4, and this the coefficient of x power 4 being 4. So from this we can actually say that because g of y, coefficient of g of y, like y power 4, coefficient of y power 4 in g of y is 1. We have just seen that. So to make sure the coefficients of x power 4 being same on the both sides, we multiply that by 4. Fine. So when you just bring this g dash of y plus 1 to this side, and this simplifying this differential equation, we get this in this form. Fine. So c can be like after simplifying this integral, we can just put c to be ln alpha. So ln alpha can be written like ln y power 4 plus ln alpha. So this turns out to be ln y power 4 into alpha, and this is ln g of y plus 1. Fine. This is what we're going to get, and from this we can say g of y plus 1 is equal to alpha into y power 4. So g of y is equal to alpha into y power 4 minus 1. So on comparing the coefficients of y power 4, and like we see that, we also know from here, we see that the g of y coefficient of y power 4 is 1, isn't it? We must keep this in mind. So keeping that in fact, keeping that fact in our mind, so we can say that alpha will be equal to 1. So the equation that we are getting is g of y is equal to y power 4 minus 1. So just put x in the place of y, we get this g of x is equal to x power 4 minus 1. And what are the roots of this equation? This is a like four roots of unity, so that is 1 minus 1 I minus I. So when you just multiply, we get the answer to be minus 1. So this is all like this is the complete solution of the problem. So I'm a bit hurry, just because taking all the things like time factors and all, I just don't want to prolong this video, and I made sure, like, at least I tried my level best to make sure like everyone understands that. Like, still if you face any problem, I can just comment in the comment section, so that I can just explain like accordingly. So this is all for today, guys, and thank you for watching, and happy Diwali.